Welcome to Home Learning. I'm Yvonne Dlamini. Today I'll take you through a topic called data handling. Data handling is a form of a topic that deals with information that have been collected, and once that information has been collected, we present it in the form of a diagram or maybe in forms of diagram. Once they are presented in forms of diagrams, it becomes a lot more easier for someone else to access or to understand. We need to go out and collect this data. First of all, before collecting that data, you need to know exactly what you are looking for. For example, if maybe you are asked to collect data on terms of soccer, let's say maybe in the classroom, your teacher asks you, how many of you favor a certain team? Maybe, let's say it's Kaizer Chiefs or Pirates or Sundowns. The teacher is going to ask you, how many are for Kaizer Chiefs? You raise up your hand. That data has been collected. Let's say maybe you are in a class of 15 pupils. 5 pupils go for Kaizer Chiefs. And then for Pirates, 3 people put their hand up. That is 8. And the rest, that is 2 pupils, they go for Sundowns. Those numbers under those soccer teams, that is the example of the data that has been collected. Once that data has been collected, it needs to be presented in a form of a diagram. There are many types of diagrams that can be used to present the data that has been collected. I'll just highlight the others, but I'll concentrate on pie charts. One of the examples of the diagrams that can be used to represent the collected data, it could be the bar graph. The word bar graph. From the word itself, it says bar. You have to think of bars, maybe a bar of chocolate. So it means that diagram, look, the information is being presented in a form of bars. I'll take the example that I've given you later on in terms of team. I'll call Kaizer Chiefs Team A and call Pirates Team B and call Sundowns Team T. Over here, those are the names of the teams. Team A, Team B, Team C. So it means on your x-axis, so it means we are going to have numbers. I've got a 0, 1, let's say 2, 4, 6, 8, 10. It means on the y-axis, I'm going to plot the number of pupils who rose their hand up for that particular team. What you need to know with the bar graph is that those bars, they don't need to be attached to each other. They need to be detached from each other. They need to stand on their own. Most of you, they confuse a bar graph with a histogram. So now I'm going to give you an example of a bar graph. You remember for Team A, which is Kaizer Chiefs, there were 5 people who rose their hands up for Chiefs. And for Pirates, which is going to be marked with a B in this graph, there were only 2. And for Team C, which is Sundowns, there were 3 pupils. This is a class of 10 pupils in all. So I'm going to plot that information that has been collected in this graph. So for Team A, on your axis, you plot where your A is, and then start drawing a graph or maybe a bar that is where 5 is. In this case, our 5 is between 4 and 6. So I'm going to try and plot my bar, which is going to present Team A. Then you can shade it if maybe you are happy with shading. Okay, that marks that there are only 5 pupils that lag the first team, which is Kaizer Chiefs. So the first thing that you have to note when plotting, go to your x-axis. The x-axis are those items on your horizontal direction. Here it's A, which is Kaizer Chiefs. We've plotted that. Then you draw your graph up to that number that marks the total number of pupils that like Kaizer Chiefs. So in this case, we've got 5 pupils. So this bar on its own can tell us the number of people that like Kaizer Chiefs. Let's move on to the second team, which is Pirates. All right? You go there and find out how many pupils like Pirates. There are only 2. You come to your team where you've plotted your teams. That's our B in the x-axis. Locate that and then draw a bar that is going to go up until we get up to 2. It needs to be in line with the 2 up there. So you can shade it. That tells us that pupils who like or who are in favor of team B, there are only 2. Out of the whole class, the class of 10 pupils, only 2. Then let us look at the third team. Which team? Which is team C. Let's look at how many pupils are in favor of team C, which is Sundowns. Remember, that's an example. Don't open a fight there at home. I'm just giving you an example over these teams. So for Sundowns, I've got only 3 people who rose their hands up. So you come over your graph, you locate your C, which is for Sundowns, and then draw a vertical line that is going to mark the size or the length of your graph. So it's going to go up until it gets to number 3. That marks that there are only 3 pupils who like Sundowns. Look at the spaces in between the graphs. The graphs are not touching each other. Most of you, they start drawing the bars attached to each other like this. This is not correct. This is not an example of a bar graph. This is an example of a histogram. We are not looking at the histogram today. Make sure that your bars, they end up to the number of pupils, in this case, to the number of pupils who favor or who are in line with that particular team. And below, in your x-axis, you need to make sure that the size of those bars are the same. And the spacing in between is equal. You can't have bar 1 here and have bar 2 here and have bar 3 here. The space in between is not equal. So make sure that the spacing between your bars is equal. This is an example of a bar graph. So whenever you see the word bar, that must click that I have to represent the data in a form of bars. Just draw those blocks. And then on your x-axis, you plot the team or the names of whatever that you want to plot. That is an example of a bar graph. Another example of a graph that represents collected data, we can use what is known as the pictogram. A pictogram. The word pic is from the word picture. It means then that we use certain pictures or symbols to represent certain numbers. For example, there is your teacher in the classroom, ask you a question. How do you come to school? What mode of transport do you use when you get to school? Let's say those who are using bicycles, those who are using There are those who use bicycles, and there are those who use buses, and there are those who walk to school. Right. So for us to have a pictogram, we need to have a certain picture or a symbol that is going to represent a certain number. For example, if we have a face, in the pictogram, the key is going to tell us that a face like this represents 10 pupils. And if maybe we've got half a face, right? This is equivalent to 5 pupils. We need to have a pictogram like this, all right? Then on the other side, you can have the modes of transport. That is on the x-axis, we can have the bicycle. I'll mark the bicycle as A, bus, B, then walking, you C. Those who are using the bicycle, those who are using bus, and those who are walking to school. For a pictogram, maybe over those who are using bicycles, I can have this number of faces and have a half a face, right? And over here, I've got 2 faces, 2 full faces, and here I've got half a face. And then you need, from this information or from these pictures or these symbols that have been drawn, you can tell how many pupils use a bicycle as the mode of transport to school, and how many pupils use the bus, and how many pupils walk to school. Remember, the key said a full face is equivalent to 10 pupils. So here we've got 10, 10, 10, and 5. So that means how many pupils use the bicycle as a mode of transport to school? There are 35 pupils. Let's come to the second mode of transport, which is the bus. By mere looking at the symbols that have been drawn, 2 full faces, we can then refer to the key. Right? By referring to the key, we can tell that how there are 20, since each face represents 10 pupils. This is 10 and 10. Then those who use the bus to school, they are 20 in number. And on C, those who walk to school, we've got half a face over there. Once you see that a half of a face, go and refer that to your key. Keep using the key, because the key is giving you a clue of the number that is being represented by that particular symbol. So half a face is being represented by number 5. So let me ask you, how many pupils walk to school? There are 5 pupils that walk to school. Another question that can come up from a pictogram could be, how many pupils are there in this class? How many pupils were there in this class? You take a 35, those who are walking, those who are using bicycle, and those who are using a bus to school, and add them to the number of those who walk to school. That is a 10, that is 60. So how many pupils are in this class? There are 60 pupils. When we started off, no one told us about the numbers, but we used the symbols, the pictures, as it is marked in the name of this diagram, pictogram. We used the given pictures to detect the number of pupils in using each mode of transport. By adding all of them, we then got the total number of pupils in this particular class. Questions like, how many more people use bus than those who walk to school can come out from the pictogram. How many more pupils walk to school, use bus, than those who walk to school? You take your 20, take away your 5, there are 15 more pupils using bus to school as compared to those who are walking to school. Those are the questions that come out from the pictogram. What you need to know with the pictogram, you have to keep referring to the key. First, understand the key, that this symbol represents this number, and this kind of a symbol represents that particular number. So, what the pictogram concentrates on, it only concentrates on the pictures. It makes use of the pictures. We are changing the pictures into numbers, and those numbers are going to give us more information about the number of pupils in this particular class. That is another example of a diagram that can be used. Another example of the diagram that can be used to represent information that has been collected, it could be the pie chart. That is our focus today. I just want us to spend more time on the pie chart, or the pie graph. It's still the same. For the pie chart, if you want to put the information in a pie chart, like I said before, you need to go out and collect the information and then bring the information or the data, put it in that graph, and from that graph, you can then answer certain questions that have been asked based on that particular drawn graph. So in this case, I'm going to make an example. I'm going to say this is a class of, say, 15 pupils, okay? Or let's say 20 pupils. This is a class of 20 pupils, right? 20 pupils. And I'm going to give you a fraction of the boys in this class, right? Quarter, 1/4 of these pupils here are boys, right? And the rest are girls. No one has given us the fraction for the girls. But the fact that you've been given the fraction for the boys, we can work out the fraction for the girls, right? We've been told that this class has got 20 pupils. This is the total number of everybody in the classroom, right? And then we are told that the fraction that represents the boys is the quarter. The quarter is for the boys, and we are not told about the fraction for the girls. So for us to move on with the other questions, we need to work out the fraction that represents the girls. 1/4 is for the boys. And from the previous lesson, we learned that for a fraction to be a whole number, the numerator must be equal to the denominator. In this case, we've got a denominator of 4. So to make one whole, we need a numerator of 4. So 4/4 marks the total number of everybody in the class. This is one whole. This is everybody, including the girls. These are the girls and the boys, 4/4. So from the 4/4, if we take away 1/4, which represent the boys, we are going to get the fraction which represent the girls. So 4 over 4 minus a quarter, I hope you still remember your lowest common multiple. What is the LCM, which is the lowest common multiple of 4, this 4, and this 4? It is a 4. How many 4s? These 4s here, right? Into this 4, 1. 1 times this 4 above, it's a 4. I think I should highlight it. So it's a 4. How many 4s into this 4 here? 1. 1 times 1, this 1 above, it's 1. Then you subtract the 2. 4, this 4 here, minus this 1, it's 3 over 4. This tells us that the fraction that represents the girls is 3 over 4. That is 3 quarters. The fraction that represents the boys is a quarter, and the fraction that represents the girls is 3 over 4. These fractions are going to help us to answer questions like, how many boys are in this class? How many girls are in this class? What percentage represent the boys? What percentage represent the girls? What is the sector size for the boys? And what is the sector size for the girls? We need to be in a position to ask all those questions. Because if we don't have the fractions to start with, we won't be in a position to calculate the sector sizes representing the boys and the girls. Remember, we need those sector sizes to draw our pie chart. We cannot draw the pie chart without knowing the sector sizes. So I'm going to use these very same examples of 20 pupils, okay? That is the number of everybody in the class. And then I'm going to draw another column, which is for the fraction. That's the fraction column. And then we can create another column, which is the percentage column. And lastly, we can have the sector size, which is the degrees that we are going to use to draw our pie chart. Here, we said 1 over 4 are the boys. And we said 3 over 4 are the girls. Then I want you to calculate the total number of boys in this classroom. Most of you make a mistake that when the question asked like this, how many boys are in this class, they say it's a quarter. That doesn't answer the question. The question, how many, needs to be answered by a number, a counting number. And a quarter needs to be answered, that's the answer when you've been asked about the fraction that represent the boys or the girls. So in this case, I want us to start about the how many part. Okay, let's look at the boys. You are going to take your fraction, which is a quarter, multiply it by the total number of everybody in the classroom. Remember that there are 20 pupils in this classroom. So we need to find a quarter of the total number of everybody in the classroom. So we're going to say 1 over 4, which is a quarter of the total number, which is 20. You say how many 4s here? 1. How many 4s here? There are 5. 5 times this one here above gives us 5. So the answer is 5 boys. Now, we can find the total number of girls in this classroom. We can use the fraction that has been given or the fraction that you have calculated, which is 3/4 of. Remember, in mathematics, of is the multiplication sign of the total number of everybody in the classroom. So we need to find out what is 3/4 of. 3/4 of 20. How many 4s here? 1. How many 4s in 20? There are 5. 5 times the 3 here. This is 15 girls. 15 girls. We can check if we are correct by adding the number of boys to the number of girls. Remember, our total number of everybody in the classroom needs to be 20 pupils. So 15 plus 5 boys, that is the 5 boys plus the 15 girls, that gives us 20 pupils. So this can give us an assurance that we're still on the right route. Now we've got the number of boys here, we've got the number of girls. 5 boys and 15 girls. When it comes to the fraction column, we've got 1/4 boys and 3/4 girls. Now I want us to move on to the next column, which is the percentage column. Remember from the previous lesson, we talked about percentage, drawing fractions into a percentage, or writing certain fractions to a percentile form. We said that you have to take that fraction and multiply it by 100. This sign marks 100. You are drawing that particular number or that particular fraction to 100. So in this case, we are given a fraction. We are being told that the fraction for the boys is 1/4. You take that 1/4, multiply it by 100 to find the percentage that is represented by this 1/4, or the percentage that represents the number of boys in this particular classroom. So you have to start doing your division, right? How many 4s here? 1. How many 4s here? How many 4s in 100? There are 25. 25 times 1, that is 25. Remember to put the sign for percentage, that is 25%. There are 2 ways of finding the percentage for the girls. One can say 100%, which is the total percentage, subtract 25. That is the easiest way. That is 75%. So the 75% can then be given to the girls. That works out very well if you've got 2 parts. If you've got 3 parts, it might be a little bit tricky. So another way of calculating the percentage for the girls, you have to take the fraction for the girls, which is 3/4, multiplied by the percentage number, which is 100. 100, and then start doing your divisions. Right? Let's divide that. How many 4s in 4? 1. How many 4s in 100? There are 25. That 25 needs to be multiplied by this 3 to get 75. To get 75%. We can check that. We can say 75% plus 25%. Our expectation is to get 100%. Once we've added the two, we are expecting to get 100%. If you don't get 100%, if you get something less or more than the 100%, it means we have made a mistake somewhere, somehow. So 25% plus 75%, that is 100%. May I encourage you guys there at home to always do the checking up. Don't just carry on without checking, because you might carry on with the wrong numbers, and maybe you discovered once you've made lots and lots of mistakes. Okay, it's the best thing to discover your mistakes as early as possible. So I'm just encouraging you there at home that after calculating something, check so that you are sure of what you are doing and to be on the correct position to say, okay, I'm still on the right track. Don't discover your mistakes after we have gone a long way, because that will be a waste of time. You know, once you start to correct those mistakes, those many mistakes that you've already made. Right. Now on the sector size, let's calculate the sector size of the boys and the girls. Note, I'm always using the fraction that has been given. Remember, the fraction for the boys is a quarter. Then I have to multiply that quarter by the total sector size of a revolution. Remember from the previous lesson we said a revolution is equals to 360 degrees. So we have to take a quarter, that's the fraction, for the boys, multiplied by the total sector size of the revolution, which is 360 degrees. So now let us do our divisions, right? How many 4s in 4? 1. How many 4s in 360? There are 90. 90 times 1, that is 90 degrees. That is what we are going to use when we are drawing a pie chart. I'm going through these things here, the percentage, the fraction, the pupils, because you may find other times that you are given a certain percentage and you have to convert that percentage to a fraction to be in a position to calculate the sector size. So you need to be able to go through all these columns. Don't just concentrate on one column, because these columns, the number of pupils in the classroom, the fraction, the percentage, and the sector size, they work hand in hand. So after using the quarter and the total size of the revolution, we got that 90 degrees represent the sector size for the boys. I want us to look at the sector size for the girls. What you need to remember is the fraction that will represent the number of girls or represent the girls in this classroom. 3/4 is the fraction that represents the girls. So we need to make use of that 3/4 to calculate the total sector size or the number of degrees that represent those girls in this classroom. Right, multiplied by 360. 3/4 multiplied by 360, we need to divide the 360 by the 4. How many 4s here? 1. How many 4s in 360? There are 90. 90 times 3, that is 270. 270 degrees. To check if we are in the right track, we have to take this 90, the sector size for the boys, then we have to add it to the sector size for the girls, which is 270. Our expectation is to be a 300 total of 360 degrees. 90 plus 270 is 360 degrees. You get something more than 360 degrees, you must know exactly that you are wrong. Or maybe something more or maybe less, you are on the wrong track. So in this case, 90 plus 270 is exactly 360 degrees. For us to be in a position to draw a pie chart, we need to concentrate more on this section, which is the sector size. I want to give you examples of fractions that have been drawn or maybe changed or converted to sector sizes. Let's say maybe you are given a decimal fraction, 0.5. 0.5. What you need to do is that you have to be in a position to convert 0.5 into a proper fraction, into a common fraction. Remember, we said we take the 5, take it as your numerator, over the comma represents a 1. How many numbers after the comma? Only one number that represents only 1 0, which is 5/10. You can then simplify that to make things a lot more easier for you. How do we simplify? Find the biggest number that can divide this 5 and this 10, right? Which number is that? Right? I can assume that a 5 can go into 5 and go to 10 and leave no remainder. And I assume it's the biggest number that can divide these two numbers. How many 5s in 5? Only 1. How many 5s in 10? There are 2. We have converted this 0.5 into a half. Most of you are familiar with common fractions than decimal fractions. If you come across a question giving you a decimal fraction, don't hesitate or don't panic. Just convert that decimal fraction into a common fraction and then make use of that common fraction to calculate the sector size. So in this case now, we've got 0.5 as 1.5 multiplied by the total sector size of a circle or the full revolution, which is 360 degrees. Right, and start doing, you can then start doing your divisions. How many 2's here? 1. How many 2's here? The 180. 180 times 1, that is 180 degrees. This is what is going to be plotted in your pie chart. This is what you are going to measure in your pie chart. Most of you, they get confused when they see decimal fractions. Convert them to common fractions and then move on to your sector size. Some other times, you find that we use percentage. We use percentage to represent certain items. Let's say they say 10% of a certain class, like black, like a black color. That doesn't mean that 10 pupils like black. The question says 10% of that number, total number of pupils in that classroom like black. So what we need to do is to unfold the 10%. There's a number behind 10% that has been hidden. So we need to unfold, what is this 10%? Right. So we need to know the total number of pupils in this particular class. Let's say this class has got 300, let's say maybe it's a school, the total number of pupils in this particular school, it's 300. The school has got 300 pupils. And we are told that out of the 300 pupils, 10% like the color black. So we need to unfold this 10%. How do you do that? Take your 10% and write it as a common fraction. Remember, we said you have to take the 10, make it your numerator, and the sign percentage means over 100. And then you can then simplify 10 over 100 by saying how many tens here? 1. How many tens in 100? There are 10. This is 1/10. You haven't unfolded the number of those pupils that like black. We're still on our way to finding the number of pupils that like black. So now we've got this common fraction, which is 1/10, which is equivalent to your 10%. This is another way of writing 10%, and that's the easiest way of writing 10% if you want to find the number of pupils that like black. Or if maybe you want to calculate the sector size that represent those who like black. So let's multiply this by the total number of pupils in this class. That is 300 pupils. How many tens here? 1. How many tens here? 30. 30 times 1, it means the total number of pupils that like the color black is 30. 30 pupils like black. But in a case of a pie chart where we need the sector size, we have to take the fraction that has been calculated, which is 1/10. We need to multiply it by the total sector size of a revolution, of the sector size of a circle, which is 360 degrees. This is going to give us the number of degrees that represent those who like black. How many tens here? 1. Remember, I said when you divide a number that has got a 0 on the far end by a multiple of a 10, you have to cancel just the 10 on the far end. So how many tens in 360? It's 36. Then 36 times 1 is going to give us 36 degrees. This is the sector size that represent those who like black. We don't have to use the number of pupils in the pie chart. We can't use that. But we need to use sector sizes, which is the number of degrees, to plot a pie chart. I want us to look at an example and where I'm going to show you how to plot these degrees in a pie chart. I'm going to give you an example. This is a class of 20 pupils. 20 pupils. Okay, maybe I can use this example that we used the other time of the boys and the girls. We said the quarter is for the boys and 3/4 were the girls, right? And then let's do the sector sizes. We said a quarter of 360 degrees, right? We said how many fours here? 1. How many fours here? 90. So we said the boys are represented by 90 degrees, while the girls are represented by how many degrees? We take the fraction for the girls, multiply it by the total number of the revolution, which is 360. How many fours here? 1. How many fours here? 90. 90 times 3, that's 270 degrees. How do you plot that? in a pie chart. Now we've got the sector size 90 degrees for the boys and 270 degrees for the girls. Let's look at how to plot that in a pie chart. Remember that the boys, we've got 90 degrees. I'll put it on the far end, the boys, and the girls. We found that they are represented by 270 degrees. What you need to remember when you are drawing a pie chart is that, first of all, we have to think of a relevant title. What is your pie chart all about? What is it telling us? What is it all about? When you look at the charts in your classroom, if you have charts in your classroom, there is no chart without a title. Rivers of Swaziland or the map of Swaziland, there is a title. From that title, you can tell what that chart is all about. Same thing with your pie chart. Before drawing your pie chart, you must have a title, a relevant title. The title must tell us more about the pie chart. So in this case, maybe we can think of a title and say, the number of boys and girls in the grade 7 class. The number of boys and girls in the grade 7 class. A pie chart showing the number of boys and girls in the grade 7 chart. After writing the title, underline it, right? And then you can start constructing your pie chart. What you need to have your 30 centimeter ruler, not something which used to be a 30 centimeter ruler, because some of you have got broken rulers. They used to be 30 centimeter rulers, but they're normal 30 centimeter rulers. Make sure that it starts from a 0 to 30 centimeters. And you also need to have a pair of compasses, right? And then you have to have a pencil, all right? And then to plot, or maybe to construct your pie chart, you have to take your compass and draw a full circle, all right? A full circle, right? And remember, your circle is going to have your center. And then from your center, you can draw a radius. That is from the center to the circumference. If you remember from the previous lessons, we learned that a radius starts from the center and goes to the circumference. And it has to touch the circumference on one point. Right. After you have drawn your radius, you then take your protractor and measure 90 degrees, which is the size, 90 degrees. And then once you've got your 90 degrees, which represent the boys, right, you can label that 90 degrees and then write that this 90 degrees is for the boys. Then the rest, if you say 360 degrees, take away the 90 degrees for the boys. What are you getting? You are getting the 270 for the girls. We can confidently put this over here to be 270 degrees. 270 degrees for the girls plus the 90 degrees for the boys gives us 360 degrees. Please don't forget to label your diagrams. Your teacher must see that the 270 is for the girls and the 90 degrees is for the boys. I hope we can now we are now in the position, we are now able to construct pie charts. We have to first start by calculating those sector sizes. We cannot draw a pie chart without knowing the sector sizes of those particular things that you are calculating. So now, I think with that information, we can be in a position to answer questions pertaining a pie chart. I want us to look at certain questions pertaining pie charts. In a class of 60 pupils, 0.2 like apples, 1/6 like oranges, and the rest like pears. I want you to underline the key words here. We've got 60 pupils. That's the total number of everybody in this particular classroom. And we are told that 0.2 like apples, while 1/6 like oranges, and the rest like pears. Most of you end up concentrating on 0.2 and 1/6 and forgetting that there is a fraction that is hidden over the word which says the rest like pears. So you must remember that there is a fraction that is hidden over there for the pears. Let us answer the question. How many pupils like oranges? We need to go to the question and locate the fraction that represents those who like oranges. In this case, 1/6 represents the fractions for those who like oranges. So take your 1/6, multiply it by the total number of pupils in this classroom. We are told that there are 60 pupils in this class. So we have to say 1/6 of 60. How many 6s here? 1. How many 6s here? 10. So 10 times 1, that is 10 pupils. Please put the number pupils. This is a problem-solving question. So make sure that you put your number pupils. Right. Let's go to the next question. What percentage of pupils like apples? If you go back to your question, your question said 0.2 pupils like apples. Right. Let's go to our question there. So our fraction for those who like apples is 0.2. 0.2 is a decimal fraction. So we need to convert the 0.2 into a common fraction. We've got a 2 over, we take the 2 as our numerator, comma as your 1, and how many numbers after the comma? Only 1, that is 2 over 10. Let's simplify the 2 over 10. How many 2's here? 1. How many 2's here? 5. So the fraction for those who like apples is 1 over 5. Remember, our question said what percentage? So we're still going to get our percentage that represents those who like apples. Take your fraction, which is 1 over 5, multiply it by the total number of percentage, which is 100. How many 5's here? 1. How many 5's here? 20. 20 times 1, that is 20%. It means 20% of everybody in this classroom like apples. I think you have understood everything that you have talked about. Things that you need to remember when you want to construct a pie chart. You need to know the fraction that represents those particular items and use those fractions to multiply them by 360 to get the total sector sizes of those particular things or those items. We use 360 degrees because the total size or the sector size of a revolution is 360 degrees. When we are calculating percentages, we need to take those fractions, multiply them by the percentage number, which is 100. And when calculating the questions, how many, you have to take the fraction, multiply it by the total number of everybody in the classroom. One more thing to remember, you must have all your equipment when you are just about to construct your pie chart. I hope you've enjoyed today's lesson. Until next time, from me, it's a goodbye. Till next time.